Thanks everyone for coming to this joint kind of demo and webinar between Preset and Firebolt. So today we're going to showcase basically some awesome charting and dashboarding experiences and just really show off the speed that Firebolt can bring really to any dashboarding tool, but specifically, Firebolt and Preset work super well together. So we'll be showcasing some of the awesome work there. And I'll hand it over to Brian. Actually, I'll do a quick intro before that. So my name is Srini. I work as a developer advocate at Preset. If you've been to some of our events, you may have seen me in the past. And I'll let Brian and Todd introduce themselves and take it from here.
Yeah, sure. So thanks, Srini. Yeah, my name is Brian Bickell. I am a technical alliances director over here at Firebolt.
And I'm Todd Beauchene. I'm the partner solution architect. So I support Brian in working with our technical partners, and I, build out. I'll be doing the demo today.
Yeah, so that's us. Yeah, I guess if we're ready to get started, I'll kind of jump into talking about Firebolt a little bit. Yeah, I mean, as Srini kind of set us up for, at Firebolt, what we're really focused on is building a cloud data warehouse for the fastest analytics experiences. And, obviously we build on the big sort of cloud data warehouse tradition started by a bunch of other vendors, but we do things in some novel ways that we want to talk about today. First off, I do want to talk about some of our founding team and kind of who we have on board. We have a lot of folks who came over from Sisense. Our CEO and founders are from Sisense. VP of Alliances and GM of Americas from Looker. A lot of our database team and CTO came out of Google BigQuery, and then VP of Solutions Architects is from Imply. So we have a lot of database talent on board, and a lot of folks who have seen a lot of this industry and been involved with it for the last decade or so in the cloud. And we raised a decent amount of money to kind of fuel the rocket with what we're trying to do here, and that includes 164 million from our A and our B round, and then another 100 million that we just closed about 2 months ago from some really great investors. So really happy to have those guys on board, and really happy that they believe in the vision of what we're trying to produce here. And maybe to talk a little bit about the kind of history of what we're building on right now. Really, the last decade in cloud analytics has been really great for cloud data warehouses. There's a lot of other vendors here that have done some really great work bringing data warehouses finally into a completely self-service SaaS sort of model. That's compared to where I started in this industry, where it was a lot of on-prem SQL Server and Oracle and things like that. So the last decade's been really amazing for this. These databases have brought us distributed computing with these scale out workloads where scale is not a problem anymore. We can address gigabytes, terabytes of data, and we can keep infinitely adding data because of decoupled storage and compute. You can keep adding more storage to any of these products and not scale CPU that you don't need or RAM that you don't need. And then serverless architectures have even removed hardware altogether in platforms like BigQuery or Athena, where you're not really even considering what node you're running on. So these have all been really great, additions to the data warehousing in the cloud, and they've made things a lot easier for users. But doesn't mean that everything's completely great. What we've run into now is that we're starting to see customers that have exceeded the capabilities of these platforms, and really this is the problem that Firebolt was created to address. As the customers that we've worked with and that we've seen in the industry have accumulated more and more data, as we say, gigabytes are or terabytes are the new gigabytes. If you don't have terabytes of data yet, you will eventually. And trying to address all of this data at a really granular level for your analysis is going to cause you performance problems. So that's what we're focused on solving with Firebolt as a cloud data warehouse. In addition to that, a couple of trends in how users have changed using the data in terms of what kind of applications they're building. This comes from places of internal BI workloads being the most common usages of data warehouses to things like embedded BI and customer-facing analytics, or what we're observing with data applications. These data applications have much more rigorous performance requirements and performance expectations than maybe your traditional dashboarding application does. And at Firebolt, we believe that a user experience where a customer's waiting for 10 seconds or 20 seconds for a dashboard just isn't good enough, and we want to power experiences that are loading in sub-second. And especially with our partners at Preset, we think we can do that. We want to show you that today. And again, one more thing here, customers are really having to make trade-offs in their existing platforms to solve some of these problems that we want to get them out of at Firebolt, such as having to aggregate data, removing detail from analysis, from maybe only looking at 2 weeks of data at a time instead of 8 weeks of data at a time. At Firebolt, we want to give you access to all of your data to be able to do really sort of granular analysis, be able to run these massive analytical queries over all of it, and we want to give it to you as fast as possible. So if we are kind of powering these next generation analytics experiences, we want to do it with a couple tenets here. We want to be incredibly fast and efficient. We're always going to show customers that first in any POC that we do. Our goal is to be able to deliver sub-second analytic experiences at terabyte scale, while doing it in a modern cloud-native architecture that is very similar to maybe what you're already going to expect with a Snowflake or a Redshift or any other platform that you're used to. With things like decoupled storage and compute, being able to tune engines to the specific workloads that you're trying to accomplish. And then we also really want to provide an experience that is built for developers and data engineers by providing them the APIs, the SDKs, the SQL compliance they need, and lets them deliver the applications in the cloud as fast as possible. In terms of kind of what's under the hood and maybe how we accomplish some of these performance goals, we're really built on a few principles as far as really trying to move around and scan a lot less data than other platforms. We do have some improved sort of indexing techniques, around things like aggregating indexes, join indexes, and sparse indexing. These allow us to make some advantages and some gains over systems like micro-partitioning that Snowflake is famous for. In our sparse indexing, we can point to very small data ranges within files to allow us to filter and find the data that we're looking for very quickly. And then our file format is something that we're quite proud of. We call this the FFF file format, and it is a sorted and compressed file format that allows our performance optimizations. So if you look at us from an architecture perspective of actually using the platform, our goal is to sort of look like other platforms that you're used to, but be easy to use, be a lot more performant, and power these sort of next generation data applications. So yeah, we're cloud native from the ground up. We have a decoupled storage and compute. One advantage that we do have that's sort of unique is our engines, which are maybe an analog to a virtual warehouse and a platform like Snowflake. They are very tunable. You can actually change the specific instance type in the engines. And instead of having to, say, double an instance type to get a little bit more performance, you can change to an instance type with a different mix of CPU, memory, or disk. And yeah, so that's kind of where we're at. And I'd like to kick it over to Todd now to take you through a demo of Firebolt.
You're muted, Todd.
Thanks, Brian. Thanks, Srini, for pointing that out. Always trying to juggle mute here. But anyway, I'm going to walk you through a quick demo of Firebolt. So we're gonna walk through the web UI. So as a SaaS platform, we have a fully web-based UI. And one thing I wanted to point out, our documentation actually just became publicly indexed on Google. So at docs.firebolt.io, you can go directly. You can search within. Someone had earlier asked about window functions. You can very easily select the subject like window functions and learn all about it, or you can go through our documentation. So very much something that, is there now to learn about Firebolt. And when you come into the actual app, we've kind of got three main screens. So this is the databases screen. So I can have multiple databases. Each database is located within a region. In this case, it's in US East 1. And the reason why I'm going to be in US East 1 is that I have some data sitting in S3, here my Amazon window, and these files, these folders in S3 contain Parquet files. And I'm going to want to load those into Firebolt. So I'm going to pick the region where my S3 files are located to get started, and that's where we're going to access it. But I can access this from anywhere. So, the region is not a limiting factor. And you can see this is a brand new database. It doesn't have any size, but I can kind of scroll down and see some of the other databases that have been created. And you'll notice they all have engines. So while we do separate storage from compute, we do tie databases to engines, and that's done for performance reasons, so that we can store, index, and cache data within the engine for the particular data set that we're working on. Now, we've spun up a very large engine here. Typically, you can get down to 30 cents an hour of compute in Firebolt. We're going to show that here in just a second, but we've spun up a pretty large instance because we're going to load a lot of data and we want to load it very quickly. But you have that flexibility to decide based on your needs. So I'm going to go ahead and edit this engine, and I'm just going to show you what the process is to create a new engine. And so editing the database allows me to then add as many engines as I want. The first thing I'm going to do is decide whether it's a general purpose or a data analytics engine. We find that for a lot of purposes, we only need read-only. And so we can set up a data analytics engine as a way to read the data. Now, when I'm defining an engine, one thing that's going to determine both the performance and the cost is the engine spec. So we have currently 4 families of engines. These are all based on EC2 instances in AWS. You can see we have our C5D class, which is a compute-heavy class. And you can see we start at 30 cents an hour all the way up to 1060 an hour per node. And then we have the optimized for storage, also optimized for ingest, I like to say, because the i3s have great IO capabilities. And so you can pick one of those. You can pick an R5D, which is for memory. If you're doing a lot of joining or a lot of aggregating, memory can be constrained, and then balance is kind of in the middle. So I'm actually, most of the time when we're querying, we're going to pick something along those scales, and I can go all the way down to 1 very often. 1 is going to be easy, and then I can update the database, and now I have 2 engines available to me. But the most important thing being the actual running engine, because to see anything, I need to have a running engine. So when I go into our SQL workspace, then we're going to see that there's no data in this database. So we're going to go ahead, because the engine is running, and we're going to go ahead and just run the script. And we're going to notice the first thing it's doing is creating, and I'm going to run it in the background, and then we'll kind of talk about what it's doing. So we're creating an external table. And in Firebolt, that is a definition that points to an S3 bucket. So this S3 bucket that's specified here is the same S3 bucket that we were looking at a little earlier. And we're going to bring in the data, and we're going to filter it to only objects that say account in them, have account in it twice because it's the folder and the file name, and then a type Parquet. And that's going to create for us an external table. When we look at that, we can see all of the column definitions. Those need to match, in this case, the Parquet file that we're going to bring in. And then we go ahead and create either a dimension or a fact table. So in Firebolt, everything is either a fact or dimension table. And I just want to point out, this doesn't mean that we have to exclusively work with dimensional data with third normal form table. We are looking at the fact that a dimension table is typically a smaller table that's going to join to other tables, and that a fact table then would be a larger table, and we're going to actually shard that table across the instances as we bring up compute and as we work with it. So just something to note, if you don't know what type of table you're creating, typically you're going to want to create a fact table. But here we know that the account data is relatively small, and we're going to create that table. So typically the external table and the internal table will have the same data types. They don't always have to. In fact, we've added 2 columns here for a source file name and a source file timestamp. So that's metadata that Firebolt automatically makes available that you can bring into your table. But the big difference here is we're defining a primary index. And in this case, it's a single column because we're going to be doing lookups on this table. So it is an ID, and notice we have a little syntax in there for accelerating joins. And then to actually get data into the table, we're going to select from that external table, and we're going to bring that data into our dimension table in this case. And just looking down, we have another data set here, the owned apps that we're creating. Again, a dimension table with a very simple primary index. Dimension tables don't actually need a primary index, but this is going to determine how the data is sorted, and it's a descending sort. So if I have, in the first case, I had one column, in the second case, I have two columns, and it's going to sort first by ID and second by app slug in that case. And so as you work with your data, you'll kind of learn how these indexes go, and typically it's going to be how you're joining or how you're querying, and especially when you get to fact tables, it's going to be how you're filtering. So I'm going to scroll down here to our first fact table, and it's LTV underscore external is the first, and we're going to then create the LTV table as a fact table. This is quite a bit of data in here. And again, it's in our S3 bucket. And you can see here as we create this fact table, then we're going to have 3 columns in our primary index. And the reason for that is that typically, and you'll see when Srini goes in and looks at this data, that the timestamp is often kind of one of the most commonly used fields that we see because people want to do time series analysis. Media source then is something that we're going to filter by in the dashboard. And so filtering fields are kind of primary, very commonly used in the primary index. And then app ID is another one that we're going to filter by. So as we're creating that, and the other thing that you'll notice is that LTV timestamp date is not actually in the data that's coming out of S3. We're calculating it as we bring the data into the table. And so we're defining primary indexes here. Now, in addition to primary indexes, Firebolt supports something called an aggregating index. And again, I point you to our documentation to learn a lot more about aggregating indexes. But in this case, what we're doing is we're taking a number of columns, and the first few columns in our aggregating index are what we call the group by column. Often these can come from a specific query that you're going to run or a set of queries. These are the columns that are going to group by in this aggregating index. Now, an aggregating index is very similar to a materialized view, and that's going to give us very fast performance. Now, I don't have to specify, other than the table on which this exists, I don't have to specify anything other than that, and it will automatically take any query that qualifies and run them instead of on the base table on the aggregating index table. And you'd be able to see that in our explain plan as you're looking at that. But the key thing to note here is that in order for a query to hit an aggregating index, the aggregating index has to have the full set of columns. Now I can query just a few of these columns at one time, but to get that aggregating index, I have to have those columns in the definition of the aggregating index, and then it will automatically. So if I were to query by app ID and timestamp date, it would hit the aggregating index, and that would reduce significantly the amount of data scanned. So really, when you're thinking about Firebolt and how to get the performance that you're looking for, the combination of primary indexes that allow us to create a sparse index across the table and very quickly filter data, and the aggregating indexes that pre-aggregate important data sets allow us to really get the performance that you're going to see when Srini does the demo here. And you can see we've continued to go. We're loading the second table, but every step is tracked, and you can see what each step is taking and how those tables start to appear. We've now got 3 different tables on our instance. I can look at the external tables as well and see those external tables. We can create multiple dimension tables. Here we're creating 2 to show that we use a join index. We're actually going to use the join index table in our example today. And this is really just working with Firebolt. Now I can save this script if I want to. So I can save that either for myself or for others. We're going to call this the load script. and that's going to then put it into my database scripts, and I can make it a global script if I want. And that allows me to share with others. And so anyone coming into my instance can then see this script. Notice we have 2 global scripts. That is at the entire account level. So again, kind of pointing out here, an account, when you create an account, you will only see the databases for your account. And you have users in that account, and then, like I said, databases, and then within each database, there's a set of tables. So when you connect then, as Srini is going to show, from preset, you're going to specify not only the database you're going to use, but you're going to specify the engine to which you're connecting in order to get the performance that you want, so that you can redirect your queries to that particular engine. And you can have as many of these engines as you want, and as many of the read-only engines as you want can be running at any given point in time to spread your workloads. Last thing I want to show you here is user management. Now, only administrative users have access to this table, but you can see your list of users. We're operating by email as the unique ID, and I can manage, I can add users, invite new users, and really control the access to my database. And so those are all in this single interface and give you the ability to really interact with your data as you're working on it. And you can see now we're finally at the point where we're inserting into the LTV table. Now, for the demo, we've got a separate database that Srini is going to connect to, so don't worry about if it's still running as I hand it over here to Srini. But hopefully you've been able to get a good feel for how our interface works. You can run SQL, both queries and load statements, and you can run other queries as those are running. So if I wanted to do, like, as a quick example now, I've already got the show tables output there, but I can run a show tables, and that's going to run, and it's going to show me all of the information about those tables, and that can run in a separate session. So I can have as many of these sessions as I want. Again, save those scripts for later. So I'm going to turn it over now to Srini to walk through the preset side.
All right, sounds good. Let me start by sharing my screen. Hopefully everyone can see this. Awesome. So I like to kind of start with the punchline sometimes in the beginning. So this is kind of just kind of showing off some of the work that Brian and Todd have done, just like building towards it. So here in this is Preset Cloud, which is just a hosted version of Superset, and each of these are basically separate chart objects. If you look at any specific chart object, you'll notice the biggest thing you'll notice is just the queries are very, very fast. We hit run, and in under 0.27 seconds, so this is about a quarter of a second, we're getting a sum, being applied to 100 million rows. So pretty awesome. You'll see the cache thing right here. So there's a little bit of a caching you can optionally turn on. If you hit it, then you'll see it run more fully and kind of see the full performance. So a lot of data scanned and not much time at all. And so this is really kind of impressive. It's definitely kind of one of the most fastest databases that I've used, especially for a lot of the analytics and OLAP type of workflows that people do in dashboards. So here we have a dashboard that has a bunch of charts in it. And the way filters work here in the left corner is that they're basically just mutating the query. So preset is basically a very thin layer over your database. Some people even called it like a little bit of a front end for your database. And I think that's a helpful metaphor because really we're in an era now where the way we think about it is the old generation of BI, data warehouses were not very fast. So they spent a lot of time building kind of essentially their own database, really, which they call the caching layer or ingestion layer. Our philosophy really is, let's lean on how fast and awesome data warehouses are now to do all this heavy lifting. And we have a very, very thin caching layer on our side, really just for, if you're going to show the exact same thing to 100 million people, then, fine. If it's the exact same chart, you can cache it. You're just caching the final results. But we always push people, if you can handle it, if you have a database like Firebolt, that's obviously going to work out much better. So all of these filters on the left are really just mutating the queries that are sent. And so if we change the date range here, so this is kind of 2018. This is January, February, March, the third month. So March 1st, if we restrict the range down, for example, and apply, this will apply to every filter here. Whoops, forgot to hit apply. So let's move it back a day, hit apply. So this is going to be, when I hit apply filters, this is going to kind of query Firebolt directly. And you'll see how quickly everything updated, basically. And even some of the delay is actually just because of preset rendering things. Any given query is actually done very quickly. And so we can kind of dive in a little bit more. Here's kind of a daily funnel chart. So again, ton of rows queried here. We have kind of metrics and some aggregates that are computed. And all of this is working great. Again, you can hit the force of the cache and you can see how quickly everything is loading. So this is kind of a little bit of the punch on up front. I'll kind of talk then now about how this stuff actually works. So for people who are new, Superset is a modern open source BI platform. We kind of work with any SQL speaking data engine. We have a large diversity of chart types. I work at Preset, so we offer a hosted version of Superset, and we have a free tier for people who want to replicate what we've kind of demoed today. From kind of a philosophical standpoint, the way we think about it is there's two main kind of core workflows. So we have Explore, which I showed a little bit of, the kind of no-code chart building experience. And in this situation, you've kind of linked up your data sets, either physical data sets or virtual data sets, which I'll talk about a little bit later. And Superset's backend is essentially generating queries on your behalf. So this is kind of really enabling folks that are not necessarily, where SQL is not their native language, to still build charts and build dashboards. And from kind of a data infrastructure and data engineering side, as long as you kind of couple the kind of and educate people around how to really get performance. So, tying your aggregating index strategy and your performance strategy to your kind of dashboard building strategy, so that every time you're running a filter, you're kind of making dynamic dashboards. Ideally, you are taking advantage of these performance optimizations, and you're not just hitting the raw data. So you're getting the best of both worlds there. We do also have a SQL editor. It's very similar, and I'll show in a second. It's very similar to the one even the Firebolt UI has. We focus mostly on read-only queries here. You can enable DML if you'd like, but really this is just for kind of writing some basic transformations or writing virtual data sets and then publishing them to Superset's metadata layer. I would not use this as kind of your full-time SQL IDE necessarily. You might want to use DataGrip or something else if you really need to kind of bang out a 1,000-line SQL query. So just a quick showcase here. Explore. You pick options on the left, and it turns into a query, and then that query is sent, and then a chart is rendered. For people who are curious, behind the scenes, Superset uses SQL Alchemy. This is actually one of the main ways that we were able to build an integration very quickly with Firebolt, because they'd already invested a lot in doing a lot of the heavy lifting in building a DB API driver and a SQL Alchemy dialect. And so we really just needed to add about a page of code, and you basically unlock all the features that you need in Superset and Preset as well because of it. So pretty nice. We kind of bet on this abstraction layer so that we can quickly add support for all these cool new databases that are coming out. So a little bit about Semantic Layer, which I'll showcase in a second. We have a very thin Semantic Layer. It's really just for doing things like calculated columns and metrics. Some of these you can even just do in your database, or if you're using a tool like dbt or transform, in many cases they may be better just living there. Visualizations, we got over 60 viz types. All of these are really just front end over a query. So anytime you're in the no code explorer tool, you're picking options. At the end of the day, the easiest thing to remember is that all of this is just kind of designing the SQL query that will be sent on the user's behalf. And dashboard filters. I'm going through these quickly because it's more fun to just show the demo itself. And with filters, you can further kind of add more dynamicness to your queries and charts, where you can kind of go one level above, make the dashboards more compelling, but also let people come in and pick unique values, time ranges, that type of thing. And just magically behind the scenes, the queries are updated and sent to the database. So the way we've kind of set this up is, in Preset, we have a workspace here. By default, we give everyone a little examples database. So if you just want to poke around and see some charts and dashboards, you're welcome to do so. But basically, the way you add a database is you go to this plus database screen over here. We have a number of databases that we support. You just click Firebolt and you put in your SQL Alchemy string. We have some great documentation. If you're new to SQL Alchemy, we do have some documentation here on both the preset docs side and the superset docs side on how to connect. I'll actually showcase one that we've already done that's a little bit anonymized here. So with this string alone, you can kind of test connection. You'll get a connection looks good. And if you have running into issues, you'll get a kind of a helpful error message there. If you want to do more things, like as I mentioned earlier, if you want to enable DML and do add indexes and insert rows and that type of thing, you can do that here if you really want to as well. And that's kind of a little bit on the database side. And the way within superset and preset, datasets are the primary metaphor for thinking about queryable objects. So everything, we have physical tables. So these are kind of the underlying tables. LTV, this is the table that Todd was talking about earlier. You can kind of go to edit and check out the metrics these are just there by default in preset. And here are all the columns. So a lot of these you may be recognizing it's kind of the similar ones that Todd was showing earlier. And you can also add calculated columns and metrics if you want to as well. And so that's kind of the data set side. And so here, as I was kind of talking about earlier, every chart here is really just backed by a data set. So if you need to do some type of join, you can definitely do that. But a superset kind of really just thinks about individual data sets. So, and I showed the filters earlier. And so even in this case, so media source and date range, that was kind of, I think there's one more, maybe it was platform. That was the kind of combined indexing strategy. So whenever and this is kind of what I talked about earlier, if you're linking your kind of filtering strategy to your indexing strategy, then you're really going to get the performance benefits that you're looking for. So if we kind of leave these platform and date filter criteria, but we change the media source, we kind of expect this to update very quickly, which is great. So each of these are kind of updating in under a second, essentially, even though they're querying a ton of data. So we hit cached, we can look at this again. So these are all basically under a second, which is pretty remarkable. Yeah, so that's kind of a quick overview of how this is experienced. So this is definitely, this was fun to put together, and I'm definitely not a Firebolt expert, but everything was fairly straightforward, and it was kind of really interesting to see just how much performance we're able to get. We didn't have to do anything fancy on our end. This kind of whatever queries are generated from Superset, they hit the Firebolt database. Learn about aggregating indexes and set that strategy correctly. And really within a few minutes, you have a dashboard that you can show to a lot of people, and where you're getting this type of sub-second performance. And I think that's pretty much it from the dashboard demo side. I'm curious, Todd and Brian, if there's anything else you guys wanted to showcase as well.
I think I'm good. Yeah, we did have some questions in the Q&A if we're ready for that.
Yeah, let's do it. Awesome, Q&A. So
I did have one thing.
Go ahead.
Hold on, just
Go ahead. Yeah.
Just a second before we get there. I did want to show just something kind of cool that we have on the Firebolt side. For the delay there, but I was just going to pull up the history. So as they're interacting with the database, you can then see the history on that particular engine and see all of the queries. So if you want to see the query history from everything that Srini was doing on the preset side, you can see the duration, and that's actually in milliseconds. So a lot of very fast queries, and you can see, where that was coming from. We actually set up that particular connection was set up with using a user named Kevin. So just to point out, it's connecting, that dashboard's connecting with a particular user, and it's running all these queries. And you can go in and see the actual, selection of both the table schemas if you're looking at information there, or the actual queries that come in. And so you can go through the query history in Firebolt and see what's happening on the preset side. So I think that together the tools work really well to understand that.
Yeah, that's great. Yeah, definitely Firebolt's going to show the more accurate, your dashboard's going to show the more accurate performance stats, but I think that's awesome. Yeah, I don't think I saw anything over a second there, so living up to our expectations.
Yeah, well, we'll go ahead, I think, and answer Ankit's question here, if you don't mind. I'll take this one. So comparing Firebolt to Druid. So really one of the big differences is Firebolt is really a cloud data warehouse, and it is hosted as a service. So when you go to app.firebolt.io, that's a global endpoint that we maintain. So there's not a Docker image, although we do use Docker behind the scenes, or actually we use Kubernetes, but we are using containers behind the scenes to manage the service. But there's nothing to deploy on your side. You simply connect up, and then you would know based on the account in Firebolt and the database and the engine, you would know what the connection string is. As Srini showed you, the connection string there in preset would define how it's connecting, and it's really, I guess the differences between Firebolt and Druid are really about providing the performance, they have the same goal of providing performance by using indexes and an understanding of the data, but in the form factor of a cloud data warehouse. So you're not going to just read data in S3 in a data lake. You're going to bring it into Firebolt. We're going to reorganize that data in a way that we sort it, we organize it so that, and we build the indexes on top of it to give that performance, and then we manage it. And when you create an aggregating index, we automatically maintain that as additional data comes into those tables. And so it's really a SaaS database that provides the same level of performance. And we can definitely, you can go into benchmarks. We feel like we're competitive with any of the, ClickHouse or Druid or any of those kind of, purpose-built speed query platforms.
That's great. Yeah, I can take the second one, anonymous attendee. Is it possible to show trend up and down last 30 days in the impression card? Yeah, I think you're kind of referring to the impressions. So this is a big number chart that's there by default. If you change to big number with the trend line and you have a datetime column, then it can be computed for you and included. This data set in particular that we're using, this is kind of we've just pulled out the exact table for, it's very kind of specific and just contains the total impressions. So it's very focused and it just doesn't have datetime value. But if we switch data sets, you can get that big number with trend line that you're looking for. And I'll try to dig up another example while we move on to the next question. I think this is probably better for you guys to answer.
Yeah, so I did show the history for an engine. Firebolt's still very much a product that we're constantly improving and developing on. And we've had this request from our customers that we be able to consolidate the history across engines and even across databases. And so we are currently working on a solution that will provide that. And then you could query it even from a tool like Preset. You could pull your query history and see your average response time. So something that's very popular with cloud data warehouses is to have a usage dashboard. And I'm sure that with Preset, we're going to actually develop one once that feature is available and then share it publicly so that you could pull up a Preset dashboard and see how the performance is in your Firebolt database.
That'd be awesome. Yeah, I love any of these like preset for preset type of use cases, like inception use cases are always great. So this is just a quick example. This is still with Firebolt, a different database, some flight delayed data. So this is doing day by day trend line, but if you change this to week, then you might get what we're looking for. I haven't run this query before, so yeah, may have run into an edge case there. But you kind of get the idea. So you can change the time grain that you want, and then you can get the trend that you're looking for. So I hope that answers your question. If you have a follow-up, let me know. well. Yeah, we got a few minutes, so if people have other questions, we're happy to stick around and answer. You guys only in AWS? I have a question for you guys. No Google Cloud yet?
Not yet. Definitely, one of the things I mentioned, we're still pretty early. We were founded about two years ago and really started selling about a year ago. So when you think about the go-to-market, that was very quick for a database.
Yeah.
And we've got customers that are live and very happy with Firebolt. They're saving money. They're seeing very fast performance. But the idea is to get it right on AWS and then add additional platforms. And, if I had to guess, Google will be first, given a lot of our connections through Looker to Google. We have a lot of great relationships with the Google team. And, ultimately we expect to be on all of the three major clouds and perhaps even some more depending on how it goes. But it's really the idea to build this as the, world-class database service and then to be able to port it as time goes on. We are available in a number of regions. I think our region count is currently 9, including some in Europe. We're about to add support for some Asian regions. I noticed some of the attendees are in India. We're going to be adding some support there. Although we do have customers around the globe. In fact, our first customers, since we were founded in Tel Aviv, our first customers are actually in Israel and in Europe. So
Nice.
definitely, we're expanding to the US and we've got now quite a few US customers and a large sales team in the US, but we always remember our roots.
That's great. Wow, just you guys were only founded 2 years ago, so you guys are all about speed, I think, in every manner of the word. That's pretty cool. Question about embedding dashboards as individual components, not iframes. We have yes, the answer is yes and no. We, on the preset side, we're building an embedded SDK. It's starting out with iframes, and then afterwards, shortly after, it'll be deeper. So it'll feel, you can integrate it into your Ruby on Rails app or what have you, and it'll feel more like a native integration. There are some folks in the Superset open source community that have gotten this to work. It's a lot of work. It's not really well documented. So I don't know if it is technically possible. It is a lot of work. We are working on it at Preset to make it good and really kind of integrate with the software development lifecycle a lot better. So if you want more information about that, I'm happy. You can shoot me an email at srini@preset.io, and I can pass you off to the right people internally.
And I would just add to that, here at Firebolt, we're really trying to be a developer-centric company, and we feel like, embedded BI is really something that's big, and we really see Preset, Superset as a tool set, but Preset specifically as an easy way to deploy those, content developed in Superset. As a way to really, the combination of Firebolt and Preset gives you the ability to, Preset Cloud specifically, gives you the ability to spin up an embedded data app without having to worry about infrastructure, which I think is incredibly valuable in today's world where, you could spend a ton of time trying to do infrastructure. And most importantly, it scales as you grow. So, no need to really focus on that. We get that ability to spin up a data app quickly and easily by loading the data into Firebolt and then building out in Preset Cloud. That's
great. Yeah, embedded is big. Someone said, great work. Embedded BI is going to be a game changer for Superset. Definitely agree. That is on the Preset side. We're not the only ones contributing, of course, but that's personally where we're very excited about is embedded BI. Because it's still very much a new greenfield type of thing, and we're excited for the role that open source plays in that as well. So we're excited for that, and yeah, look for some in the future maybe a Firebolt and Preset embedded event. That'd be a cool one to do. Cool. Does anyone have any other questions? I know a few people have asked. We will share out the recording. You don't need to do anything. We will just automatically share out a link to the recording to everyone who was signed up. There'll be a public link, no paywall or nothing. So just a heads up.
We did get another question about Firebolt versus Pinot, and I'll have to admit I'm somewhat familiar with Pinot in and of itself, but I think really as we look at kind of services that are hosted and we make it easy to work with, and kind of bringing all your data into a hosted platform, I think simplifies a lot of the pieces. As we mentioned earlier, I was one of the early employees at Snowflake, and it was really enlightening to meet with people and be able to take them from an on-premise architecture into the cloud and into SaaS, even more specifically than cloud, into SaaS. And while we handle time series database data really, really well, the flexibility of a fully featured, one of the things that we're working hard on is making Firebolt as robust as any cloud platform. And so really that flexibility, I think, is where we shine through over solutions like ClickHouse or Pinot and Druid. And so I think making it easy to deploy and hosting it so that the scale comes on our side is definitely something that our customers are enjoying so far.
Very cool. We have another question. I will let you take it. I think you kind of answered this, but maybe it's good to clarify further.
Yeah, just to reiterate. Yeah, so this is hosted by us. There is we've had a couple of requests actually for, on-prem Firebolt, but today it all runs on our cloud. So you come in, you sign up, you go to app.firebolt.io, you can sign up. Right now it's a gated trial. We don't have, we want to make sure you get what we call the Firebolt bear hug, where you come to, as you come into Firebolt, we want to make sure you understand how it's operating, and we want to be there to support you. So you request a trial, we'll then reach out, get you access, but it is only available in a hosted form today.
Other questions? Question from Brian.
So the way we operate, we actually use the marketplace. So the infrastructure is actually running on Firebolt AWS infrastructure, right? And you're correct in that you're going to need an AWS account in order to get billed, essentially, because we handle all our billing through the AWS Marketplace, which, there's a number of reasons we did that. Mainly that the contracts are simpler. You've already probably got an arrangement with AWS for billing, so you just use that. You create a subscription in the AWS Marketplace. But when you spin up, as you saw me, I created a new database and created tables. Those are all being stored in RS3. But we have dedicated buckets for each customer to create that segmentation. So, and then as you spin up engines, those are running in our EC2. But again, we have dedicated units for each customer so that the data is secure across customers, and it all runs in our cloud.
Yeah, that's a good question, because I think
You're great.
Yeah, there's a good nuance there, because I think when you see Marketplace, sometimes people think it's going to be deployed in your cloud or your VPC or whatever. So yeah.
Yeah, no, these are great questions. We really appreciate everybody's taking the time to listen, and your questions have been great.
Other questions? Still got time. Going once. Maybe done with questions. Awesome. Well, we can call it a wrap. I think if you do want to maybe share y'all's emails real quick in case people maybe have follow-up questions or they're ready to play with Firebolt.
Yeah, sure. So I'm at Brian at firebolt.io.
And I'm Todd at Firebolt.io. We keep it pretty simple with our email addresses. So you can reach out to either of us. We'll help get you started. As I mentioned, I'm a partner solution architect, so I specifically am the one that can help if you have questions about how Preset and Firebolt work together. You know, we have an API that allows tools like Preset to query Firebolt, and we built a connector that's available for both Preset and Superset. So we're excited to share that, and I'd be happy to work with anybody to get that set up with their data in their own Firebolt environment.
Awesome. That's Todd with 4 Ds, right? I think I heard that right.
Just two. So I guess that's an important clarification. TODD. At least you don't have to spell my last name, which is is significantly harder. So
I always get confused between Max's last name and yours, Beauchene and Beauchene. I guess that's how I maybe butcher your name.
Yeah, well, it's an honor to have a last name anything like Max's. So
great, awesome. Well, thanks for having. It's great having both of you come by. This was fun. We will share the recording, as I mentioned. There's more questions, definitely reach out to me or to Brian at Todd. You see their names right there. And yeah, I hope everyone has a good rest of the day, good rest of the week. And thanks for coming by.
Hey, thanks for having us, Srini.
Great one, guys.
Thanks, everybody.
Bye.
Cheers.